you. I'll introduce myself in a moment, but let me see, I have to. So, some time ago, a colleague of mine called me and said, Niels, I saw on your website this sentence that I said, in my experience, the zero defects attitude results in 50% less defects almost overnight. He said, that sounds interesting, and can you do a tutorial to my people, to my team? I said, okay, let's do that. And that was the start of this presentation. But then I thought, if they like it, maybe some more people like it. So that's why we are here to discuss this. Now, who am I? I coach projects to deliver better results in less time. More effective, more efficient, more predictable. Well, because most people don't think they can be helped, they usually only ask me when the project is really in trouble. We call that project rescue. And because my background is electronics, I, from time to time, do some product development, which means I have to eat my own dog food in doing the projects. So my question is, do we deliver zero defect software? Or for the systems engineers here, do we deliver zero defect systems? And I will try to use the yes, no of Zoom. So if I have a question, you can answer, everybody can answer by reactions, and for some that is under more, and then reactions, and you can say yes or no. So can people try to give an answer to this question? Do you deliver zero defect systems, software? I'm waiting for a green one. But so the way to get back from this yes or no, click again. So all the people who clicked no can click again, and then it's gone. Because I think this is enough information. I saw only several no's and no yes, which I expected, of course. So if we don't deliver zero defects systems, the next question is, how many defects are acceptable? I mean, well, let's not use that polling mechanism now. So how many defects are acceptable? Apparently, the requirements specify a certain number of defects, because I suppose that the developers do their best to deliver according to the requirements. Apparently, they deliver defects. Therefore, apparently, the requirements specify that defects must be included, right? So, and then I asked the testers, because I also present this regularly on testing conferences. The question is, do you check that the required number of defects has been produced? Or is this a strange question? So in your projects, how much time is spent in putting the defects in, and how much time is spent in trying to find and fix them? Is that about 50-50? First half of the time we put them in, and the other half we try to find and fix them, right? So then I asked testers, but others also can answer. Do you sometimes get repeated issues? That means some issue has been found, some bug has been found, and sometime later you find a similar bug. Do you? Say yes or no. So some people get repeated issues. One person doesn't get repeated issues. Two people 3 people don't get repeated issues. Apparently, they have learned from the issues, from the bugs, and then made sure they never made them again, right? So the question could be, how much time do you spend in your projects or in your team on defect prevention? 1, 2, 3, 0. So my conclusion is better quality costs less. That's simple. If you don't put errors in, then you don't have to find and fix them, where you find and fix only half of them. So better quality, the right stuff. You have to do less, therefore you have more time to do even more quality, right? But before we continue, let's define what a defect is. Now, we can make many definitions, but the definition I like, especially in this context, is a defect is the cause of a problem experienced by any of the stakeholders while relying on our results. Half of the software made is never touched by anybody. So any so-called bug in that part of the software that never is touched by anybody, that is not a bug, according to this definition. The only defect is that the software was made that is never used, right? So, question, is zero defects possible? I mean, actually I asked already, do you make it? But do you think it's possible at all? I see a few yes, I think it's possible. I see a few no's that it is not possible. Not everybody is answering, but it was about 50-50. So let's see, what is zero defects? Zero defects is not a thing that we change a knob on our mind and suddenly we don't produce defects anymore. Now, zero defects is I call it an asymptote. Remember from school what an asymptote is. An asymptote is a line that you never touch. This is the learning curve. And if you have a certain acceptable level of number of bugs to deliver, then the asymptote, the learning curve, goes to that level, because when you're there, everybody's happy. And what's the point in continuing doing your best more, right? Now, if we want to go to zero defects, the only way to ever get near is to have it as your target. So that's not a certain acceptable level. The only acceptable level is 0. And when Phil Crosby started with zero defects, he introduced the concept, errors dropped almost immediately by 40%. That was easy to count because he was in a company where they made rockets. And the rockets were test fired at Cape Canaveral. And if they put 10 rockets there and tried them, most of them didn't work. So the boss from Phil said, Phil, you're the quality guy here. Can you make sure that these things simply work? And then he explained, boss, you know, there are 10,000 components in every rocket. Yeah. So the chance that something doesn't work is very big with so many components, right? And then the boss said to Phil, Phil, I'm sure that in the world there's somebody who can make sure that all these rockets simply work. And it would be nice if it were you. So Phil understood that his job was on the line. And he started thinking how to do that and talked with his people, and they said within a short time, and that was easy countable because suddenly most of the rockets worked. So apparently it was possible. Now I also experienced the same. I was working at a company together with one of the guys who is at this moment here. Hello, Bart. Nice to see you're here. And with Bart, we learned a lot of things. And there was some handheld terminal. And the handheld terminal was crashing within half a minute. And the software people were already adding stuff. I said, guys, we can't sell this thing if it crashes. So what's the point in adding features if we can't sell it? So we decided, together with Bart, we decided, guys, can you get rid of all the problems so that it is stable, and then we can add functionality again. Okay, I went on holiday, and 2 weeks later I came back, and then I saw them adding features again. So I said, guys, is it stable? They said, well, it's much stabler. It's now not half a minute, but in 10 minutes it crashes. I said, well, if it crashes, we can't sell it. So what's the point in adding features? So I don't want, all I said is, I don't want to see bugs anymore. I want to see it crash. It should simply work, and you know how to do that. A week later, it was stable, and they were amazed. It was stable, they could touch the screen, and it kept working. I said, that's all I expect, and now you can add features. So the strange thing was, it was just an attitude that, because I said, I don't want to see bugs anymore. And that was all that necessary. It took a few weeks to let them understand that I was dead serious about it. But then they didn't produce bugs anymore. The testers were sitting in the corner, and one of them came to me and they said, Neil, something weird is going on. We don't find bugs anymore. I said, isn't that what we want? So if Phil and I, well, Phil didn't believe it first. I didn't believe it first. But when we tried Zero Defects, it simply worked. And it didn't cost anything because it was just an attitude that we didn't produce bugs anymore. So Phil had also a nice way of saying, he said, an acceptable quality level of more than 0 means that the organization has settled on a level of incompetence, causing a hassle other people have to live with. And this is an interesting word, that hassle. To me, as a non-English speaker, I had to learn what hassle exactly means, although I felt something there. And I found in the dictionary, unnecessary difficulty. And I was working with another team, and I found that it was difficult for them to use the concept of zero defects. But the moment I introduced the concept of no hassle, if you deliver your software to your customers, you shouldn't hassle your customers, suddenly they could handle it. That worked. Of course, we are not perfect, but the customer shouldn't find out. So that's the learning curve. Maybe we never touch the asymptote, but if we don't even try, we never get near. I hope the zero defects concept is already a little bit more acceptable with this explanation. Now, I was in some organization where they had Bugzilla, and they had a big database full of bugs. I think more than 1,000 bugs. Some of them were more than 15 years old. I said, can't you get rid of them? Anyway, so I said, is root cause analysis routinely performed every time? Do you do that? And in the Bugzilla, I found these two. What's the cause of the bug and the solution of the bug? And I said, can we add two more boxes? So what's the root cause and the root solution? Sometime later, I came back in that team, and then I looked at Bugzilla, and they actually put the cause and the solution here and left that open. So then apparently I had to give some more education there. I said, what's the difference between a cause and the root cause of a defect? So the cause is the error that caused the problem. Or error in the software that caused the problem. But the root cause is what caused us to make the error that caused the problem. And I was in yet another team, and there I talked about this root cause. And I said, do you do root cause on all the errors you find? On all of them? We don't have time for that, said the project manager and the architect in chorus. I said, well, apparently we have time to repair everything, but we don't have time to prevent. And prevention is so much more cheap. So without proper root cause analysis, we are doomed to repeat the same errors. Remember my question, do you see the similar issues again and again? Yes, we did. So do root cause analysis and see what caused us to make the error that caused the problem, and make sure you don't make that error anymore. Now we can ask, does testing assure quality? Because some testers call themselves QA, quality assurance. Interesting. So, can testing assure the quality? Some testers think, yeah, we make sure that quality is delivered. Yeah, so what do you think? Can you say yes or no? And those that still have their old yes and no, please get rid of them so that we have the answer to this question. By clicking again on that icon, it will disappear, and then you can select the answer to, can testers assure quality? Seems that the tone of my voice probably already suggested the answer I expect, because I see more no's than yeses. So, if people think testers can assure quality, I always use this Deming quote. Quality comes not from testing, but from improvement of the development process. Testing doesn't improve quality nor guarantee quality. It's too late. The quality, good or bad, is already in the product. You cannot test quality into a product. So, how do we create quality? By design. I know we are not perfect, but the customer shouldn't find out. And let's have some examples. So, some people think I'm from Mars. Some people think I'm too old, maybe I am, but this is my suggestion. We check what the requirement is, what we should do. It doesn't say requirements. I'm not talking about big design up front for the agile people who now start running away. No, a requirement. What are we supposed to achieve? Then we review, and if we agree that this is the right requirement, that it's clear enough, then we design, and then we review the design, and then we code, and then we review the code. And if you do that, at the integration test, there is no issue found. That is what in the 60s and 70s, a long time ago, a clean room approach to software development did. Yeah, if in test they found an issue, it was not allowed to repair the defect. You had to go back to your design and start all over again. Can you imagine if you do that once or twice? People simply deliver stuff that works. One thing is what I then ask, because often we don't find the design because a lot of software is just coded. Yeah. I say reconstruct the design, because if you don't find it. And I was at the conference in Budapest a few years ago in Hungary, and there was a guy, I think he was 80 years old or so, but he had a great presentation. He said, I organized the first testing company in Hungary. And the first module we had to test came from Siemens for some nuclear reactor. So we tested that module and we found about 300 bugs. Then we reconstructed the design. That's my words, but that's a translation of what I heard him saying. We thought, what is this code doing? We reconstructed the design, and guess what? We found 3,000 additional errors. And a lot of those errors are things you won't even find by testing. So I use there the concept of the design log. And a design log is just a concept because it doesn't have this form, but the basic idea is at the top of chapters, you say, what do we have to achieve? At the bottom of chapters, there's a decision how to achieve it. And in between, we get the reasoning, assumptions, questions and answers, calculation, possible solutions, selection criteria, and then the decision, this is how we think we are going to do it. And then after a few weeks, you find it was a good idea, but it doesn't work. So you repeat part of it. And at the bottom of the chapter, again, you have the decision. This is how we think we're going to achieve it. That's the concept of the design log. So I used this concept at a company in Ireland, and later I worked with James there, and a few years later he called me. He said, I'm now working in another company, and can you teach us about requirements? Because I have this team that I asked what's the goal of what do you have to achieve in the next sprint, and they couldn't give an answer. So he said, can you come down and let's have requirements exercise. So I went there, and that was on a Thursday, and it happened to be the Thursday that they have their pub day. Every month on a Thursday they had their pub day. So I went together with them to the pub, and then we were drinking and having some bites, and then James came with Louise. He said, Niels, this is Louise. Louise, this is Niels, who taught me about design logging. Tell what happened. And then he left. So what did Louise tell me? She said, we had only 7 days to finish some software. We were working hard, coding, testing, coding, testing, coding, testing. You may have seen that. And then James came and he said, stop coding and testing, go back to your design. Oh, but we don't have time, we have only 7 days. He said, stop coding. And apparently he came in that company at the level that he could say, stop coding, go back to your design. So Louise said, I went to the design, found the problem, corrected it, cleaned up the mess. and we were done in less than 7 days. Thank you. So I put this on the web page. If you go to my website, you can find this as DesignLog case, and there is another case. And then I sent the message to James. James, this is what I think Louise told me, and can you check with her that that my interpretation is right? Well, James answered me, Niels, the story was even more interesting. I gave the design to 2 colleagues for a review. And when Louisa heard we were going to review, she said, if you go to review, I have to do a much better job. James said, you did your best. Let's just see what happens. So two colleagues, they found some minor things. She corrected them. And then James, okay, now we go to the final review before you can go to your coding. And then a colleague who wasn't in the first review session, he found that this solution would get into the swamp deeper and deeper and deeper. So together with Louise, he reworked completely the design of the module. And that's what Louise's team had then done. And at the delivery, 5 days later, not 7, the design that was designed and code-reviewed had no issues after deployment. And guess what? There was another module her team also was supposed to deliver. And guess what? Full of defects. So James said, this was so convincing that from now on, this is how we work in this company. We're quite interesting people. This requirement exercise I had to do only once because then they understood. We're very clever people. Now, there are many ways to represent the design. And in some projects, I also said, make first the design before you start coding. And this is a picture that I took out of a document which somebody made after I said, just make a design before you start coding. Isn't that a nice picture? Now, can you see what's happening there? I couldn't. So I just looked at it and tried it in my way. Whether that's better or not, I don't know. But to me, that was more clear. I saw more structure. And what I also saw was here is a potential, here is a bug in the design. I don't know whether you see it, but I can't see your faces. So let's just tell you. This says n is not some size, n is equal to some size after n is n plus 1. Now, can you imagine if you do this test first, it's either this or that, which means this will never happen. If you can follow this and see my cursor, I hope. Yeah. So do you see that quickly in this picture? So I keep saying there are many ways to represent the design, only few are useful. And please don't waste the reviewer's time because they also have other work to do. Another example of the same company was the boss understood this idea of design. So he said, now we have this new product where we have a controller we built and we buy this little thing just like in a hotel room for air conditioning from a Swiss company. And an American client wanted this one to use to tune in the air conditioning in the room. Nowadays, people say, why don't you use your smartphone? But at that time, they said, can we use the same knobs and the display for the electrician to tune the air conditioning? And the boss understood about requirements. So he hired a systems engineer, because I heard that systems engineers know how to write requirements. Now system engineers know how to write requirements, and usually that's a huge pile of stuff. And that's what he did. He made pictures like that. Don't worry that you can't read it, because it was 47 pages of pictures like this. And you can imagine that it's 47 pages of pictures like this. It's a lot of copy paste, and therefore a lot of inconsistencies. And I asked the people both in Ireland and in Switzerland, I asked, did you read this document? Did anybody read beyond page 8? No. So I thought, can we do better? So I tried to translate these 47 pages into one picture. And then in Ireland, I explained this picture. And they said, wow, that's a simple way, and we can follow it. I projected it, and I explained step by step, and they said, yeah, that's right. And then I went to Switzerland, and same. And well, one page that they understand is easier to implement than 47 pages they don't understand. So on the train back from Zurich, back home, I thought, well, if we implement this flow, this state machine, into our device in Ireland, what would be the consequence for the firmware? So I made this translation. I sent it for review. The Swiss said, yeah, looks good. Dublin, no answer. Then a week later, I went through it again. I found a few issues. So if people don't review a few days later, and you will find issues. And the more issues you can solve, the less you have to waste time in repairing things. So in the end, I sent this to Ireland, and many months later, I was back again. It was the end of some gig I did there. So many months later, I was there again, and I asked, what did you do with this? Well, we implemented it. It worked. So some people review code. I can ask yes or no, but I assume some people review code, right? So if you review software, do you review code like this? Or is there something better than reviewing code? And by now you should know my answer. May I review the design first? Because I will probably find 10 times more issues that in the code I may not even recognize. Now, why is that? I was thinking, what's the difference there? Well, if you watch over the shoulder of a typical software guy working in code, you see somebody moving screens because in their mind they have to combine things and how things work together. So that poor brain there of the developer is having the design in his mind if it's not on paper. And if such a design is in your mind, it is fading away all the time. So you have to refresh it constantly. How it conforms with the code. And then once you understand that, you have to think, now what do I have to modify in the code? So, poor brain, can we do something about that? So, if you put the design on paper or something like that, then your own brain is there available to think what to do with it. So in some example I made many years ago, was this the state machine, this the flow diagram, and this the code. and this and that is the same. And of course, I know it is difficult to keep that in sync, but that's a matter of discipline or a matter of the right tooling. Okay. One more example. I was in a project in the UK, in Manchester, and a Scrum team was planning the next sprint. So they were thinking, they were looking at the backlog and taking things from the backlog and talking about user stories and so. So I said, guys, how can we measure that we finish this sprint successfully? What's the measure? They said, Niels, what a strange question. We're agile. We deliver working software, don't you know? Well, I said, users don't want software. They want improved performance of what they're doing. I mean, the functions people already do for ages. Banks for thousands of years, first with clay tablets, then with cardboard cards, and now with computers. Well, they still do the same. They rip the customers off. So why do we give them software instead of cardboard cards? Because they can handle more customers faster or so. If you have 100 customers in your bank, maybe cardboard cards are even faster than a computer. But if you have millions, you need a computer to handle all those customers. So it is the function is not the essence of what we make. It's the performance improvement that's the essence. So how can we measure the success of the coming sprint? How about as a requirement for the demo, they called it the demo at the end of the sprint, no questions, no issues. So we give it to some stakeholders there, and we are successful if they have no questions at all and there are no issues at all. That's impossible, they said. Yeah. How do the stakeholders know what they have to do with what we deliver? I said, well, once the computer is there and you are not there anymore, they still also have to know what to do. So you're clever people, find a way. Maybe you make a release note or so. Yeah, our total, there was a very big project with many Scrum teams. So yeah, we have a general release note. I said, no, this is your team, your success, no questions, no issues, you find a way. And then, well, somebody was already thinking, oh, maybe halfway we invite somebody and show it to him and see what happens. I said, good idea. So actually they succeeded. Well, kind of. First, about the concept of the demo. I'm sure with so many people that there must be some people at least who think they have to do Scrum. So Scrum then has what some people call the demo. Yeah. And my suggestion there is not to demo, but give your delivery to the stakeholders. Dip your mouse, handcuff your hands on your back, and observe what happens. Because seeing what the stakeholders actually do or not do, there you get the real feedback. Like that project where I asked, now can we do something in this demo? No, this is a demo, we have to show. I said, well, isn't it useful that somebody, so the R&D boss came there and said, can I do something? So the guy said, well, can you type your credit card number there? So he went to the keyboard and he typed Wim van Leeuwen. That was his name. Crash. Okay, good demo. It crashed. No questions, no issues. So see what they actually do, provide that gives the real feedback. And after that, it simply works. They didn't have any questions, but now, of course, we can get questions. Is this right, etc. Is this how you do demos? So the demo was, in this case, a concurrent database record update. Now, I don't know why 8 people spent 2 weeks to deliver this, but that's another story. Let's see how the demo went. So the demo room was in Manchester, UK, and the customer site was in another city. So via a telephone, they connected to computers, and the stakeholders were there sitting. And the guy in the demo room said, now guys, can you take the mouse and see whether you can move something on the screen? And through the telephone, we felt a thrill of excitement at the other side, because it was the first time after 2 years that they asked the stakeholders to touch the mouse. Okay, after some time, they saw the cursor moving, so apparently they found the mouse. And then he said, now, can you open some record and change something? And he did in his computer the same. He opened the same record, changed something, and saved it. And the idea was that now the customer, when the customer wanted to save his stuff, that the system said, the data is already changed, and what do you want to do? Something like that. So actually, the customer initially didn't ask a question. He only said, take the mouse and do this and do that. Well, okay. And there was no error, it worked. And so kind of, they succeeded. No questions, no issues. I mean, for the first time, I think that was quite a good result. Now, this team had a lot of trouble. And once I went together with a project manager to the customer. And on the side, this customer guy, he said, Niels, we are not going to use this junk. It's so unuseful. So on the way back, I told the project manager, I heard they're not going to use this stuff. She said, doesn't matter. We have this requirements document. They signed it with blood, and we deliver, and they pay. I said, well, then I don't have to be here anymore, right? So I left. But I left some suggestions how maybe eventually they could improve on this, which a few years later I heard from somebody they actually did. How about these delivery strategy suggestions? What we deliver will be used by the users immediately, within 1 week, not making them less efficient than before. Now that's a weak requirement, right? Not, at least not less efficient. Often they get software and things get worse. So how about that one? If a delivery isn't used immediately, because we are people, we are not perfect. If it's not used immediately, we analyze and close the gap so that it will be start being used. Because only if it is being used, we get the right feedback. If they don't use it, we don't get the feedback we badly need, right? And the proof of the pudding is when it's eaten and found tasty by them and not by us. So it's not us who decide that we deliver the right stuff. It is them who decide that we deliver the right stuff. The users determine success and whether they want to pay. No cure, no pay. Well, we don't have to tell them, but shouldn't that be our attitude? Yeah. Would you dare to deliver no cure, no pay? As an example, I work no cure, no pay. My customer can say, this wasn't worth it. We don't pay you, and I have nothing to say. This one I want to skip because of the time. So I showed some techniques. I showed the importance of design, the drawings, and some drawings are useful, some are less useful. DesignLog concept, reviewing, no questions, no issues. And the interesting thing is the attitude of Zero Defects makes an immediate difference. It took that Belgian team, it took them 2 weeks to understand we were that serious about it. And a week later, the issues were gone and they didn't introduce more. That's cheap. So the basic approach: design the requirement, review, design the implementation, review, implement, review, test, don't find issues. So, do we deliver Zero Defects products? I keep saying better quality, cost less. If anybody wants to discuss that, we can discuss it now. And if you later want to discuss, you can find my email. And I love to discuss real cases. I don't like theoretical cases, and that's why I don't teach as universities. I like the real stuff and then give, because every case is slightly different. That's what I wanted to say. And there is more, a lot of little booklets that used to be conference papers and turned into booklet you can download from my website.